Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many 5-digit zip codes are possible if the digits cannot be repeated? Now this problem seems familiar because we already done solving this using the fundamental counting principle. But this time, we are going to present another method, the use of permutation, so that it would be a guide for us as a formula to be used for similar situations. But before we could use permutation, we need to understand these two different concepts. Number one, there should be no repetition of objects to which this item falls into the category, because on our 5-digit zip codes, where in each category or each digit there's 0 to 9, there should be no repetition as given. And the second idea for permutation is that if we have an arrangement of 0, 1, 2, 3, 4, a 5-digit zip code using those same digits, another zip code which is 43210 is counted differently. In short, they are counted there will be two of them. So that's the idea of permutation. If our arrangements are different from the other and they are counted differently. Okay, so let's start with the idea here. Of course, we have a 5-digit zip code. What we did before in our permutation, fundamental counting principle, is we have 1, 2, 3, 4, 5, and we place here the number of possible digits to be placed in each of the placement, and we multiply all of them. Using permutation, we simply need to use this formula, N, P, R, where N is the number of possible digits and R will be the digits, in this case, taken at a certain time. Here, our N is actually 10 because there can be 10 possible digits for each placement from 0 to 9. And our R here is the number of digits that we could have here. Since we have 5-digit zip codes, we are taking 5 of them at a certain time. So there are 10 digits and we are taking 5 out of those 10 and arrange them into a possible order. The formula for permutation is in this manner. We are going to take n factorial over this difference, n minus r factorial. So we also need to understand the idea of factorial, as factorial tells us if we have n factorial, as mentioned in the previous videos, this is just a product of n times n minus 1 times n minus 2 until you reach a certain constant of 1 where you were able to remove all n minus 1 terms. So this time here, we simply need to substitute our n here, which is 10 factorial, over, you will have your 10 minus 5 factorial. And for some of you, this may seem longer than the previous video, and I would like you to check that previous video, but this formula is true to all now. You just need to identify the number of possibilities and the number of items taken at a certain time, and you have this formula. Of course, 10 factorial is 10, as mentioned, times 9, times 8, times 7. You're doing this if you're not using your calculators, because if you have your calculators, you can automatically input that in your calculator there, times, let's end with 5 factorial. Of course, we could end until 1 as mentioned here, but let's just have that because for 1, we don't have much space. And for our denominator, that's 10 minus 5, you will have your 5 factorial, to which you can automatically cancel here because they are under multiplication. Hence, the number of 5-digit zip codes that are possible if the digits cannot be repeated would be the result of 10 times 9 times 8 times 7 times 6. If you're using your calculators there, you will get a result of 30,240 possible 5-digit zip codes where the digits cannot repeat. this is the same as the answer we have presented before using our fundamental counting principle. Please check that previous video. Of course, if you would like me to do it here, we did it before like this. There are 10 possible digits for the first placement, times, there are 9 because there should be no repetition, times 8 because those 2 digits can repeat on the third, and of course you will have your order 7, and you have here times 6. This is the use of fundamental counting principle, which yields the same answer, 30,240 arrangements here. So this is how we use permutation in solving for these types of situations that will fit the category number 1 as mentioned. There should be no repetitions of objects, and number 2, the arrangement of objects of the same objects would be counted differently if we are going to rearrange them. So this is the answer for this type of situation, and that's counted in. Talking about getting the luck of the draw. For all in, subscribe now.